Hi everybody. We're doing SIG number 12, which is area between curves. You are allowed a calculator on this, so please, when you're doing this, get your calculator out and put it close to you. You're going to need to make sure you're showing some work on these because you're going to get points for, you're going to get the credit whether or not you set it up correctly. Basically, we're trying to find the area between curves. The general idea is that if I have two curves graphed in the coordinate plane, maybe like such, and maybe the red one's called F and the blue one's called G, then we can find the area between these curves, right? The area is going to equal the integral of the f of x minus g of x with respect to x. And then there's also something to consider, which is a and b, which in order to find those, you'd have to find these points of intersection, unless it's specifically gives you the left and right bound in the problem. And then sometimes, which you will see this as well, sometimes you might have a curve that looks like this. Maybe you have F looks like this, and G looks like this. Then you can't really do top minus bottom because like over here, notice that F is on top of itself, so we can't do that. So what we need to do is we need to write all these equations in terms of y, so what we're going to say is this is f of y, and this one would be g of y, and the area would equal the integral of right minus left, right? So this is right minus left. So basically in this case it'd be f of y minus g of y, because the f is on the right hand side, right? And then when we're talking about a and b, it's, we're talking about these points of intersection again, except we're going to be using the y coordinate, right? So if this point is something a and this point is something b, then we're using a and b as the y coordinates, right? We're finding the area going up like such. Okay, the thing to note is when I plug this into the calculator, you're going to still type the button X. It's just going to be, it'll still give us the right answer. Okay, so let's do some problems. The first one is the curve y equals 2x squared minus 16x plus 31. Y equals -2, x equals 2, and x equals 6, right? So we need to go ahead and graph these, unless you want to, try to do it by hand. So we're graphing this. Oops, I kind of did that backwards. So it's, anyway, whatever. I'll do y2 and y3. Y2 is -2 in this case, right? These are my two functions here, this one and this one. Let's make a note of this. In my calculator, I put this as y2, and this one's y3. All right, so let's see what these graphs look like. The first one is the squared, and this is the other one. We're trying to find the area between x equals -2. There's no way to graph. There's no way to graph x equals on here, so you have to know what those are, right? So x equals 2 is the line that goes through 2 like such, and x equals 6, the line goes through 6. So 1, 2, 3, 4, 5, 6, I believe. We're being asked to find the area between these curves, so basically all of this area, right? This one connects somewhere up there. I'm trying to find that area. So the idea is we're going in the towards the x-axis, so we're going to use x functions. We're going to integrate. They give us the integral, the limits, which is from 2 to 6, right? They give us those right here. That's what we're using there. We have to do top minus bottom, so you can see in the picture that the top function is the quadratic one, the one with a squared. and we're going to subtract the bottom function, which is that. I find it difficult to put these into my calculator sometimes if they're too long, so let's just go ahead and simplify it. Minus negative 2 is the same thing as plus 2, right? So it's going to be 31 plus 2, which is plus 33. Oh, I don't know why I put dy. It should be dx. So we just go into our calculator. We actually have those functions. Actually, yeah, I didn't need to simplify that because we have it in our calculator. We're simply going to do math 9. We're going to go from 2 to 6. We're going to do this one, which was, this one was the top, y2, and this one I put in as y3. So we're going to do alpha trace y2 minus alpha trace y3 with respect to x, and we're going to get 14.6666, right? So it's just a repeating 14, and you can see that is the correct answer there, right? All right, so let's keep going. Let's do the next one. Same idea. We're graphing the function y equals x cubed over 2 minus 3x and y equals x squared over 2. Again, we have a graphing calculator, so let's use that. Let's put these two functions on. We're going to do x to the third divided by 2 minus 3x, and then the other function we're going to use is x squared divided by 2. And we graph, and we can sketch our own little graph over here if we want to. The x cubed one looks like this, right? That's the green one. And then the other one looks like something like this. The region we're interested in is this region right here. So we're going to integrate. The area is going to equal basically top minus bottom. So the green one's on top, so it's going to be x cubed over 2 minus 3x, because that's what's on top, minus the bottom function, which is x squared over 2. Don't start squaring these, right? Because we just learned about volume. You don't want to like start squaring them, or you don't want to put a pi over here because we're not doing volume, right? What I'm missing is what are my limits. In this case, the limits of integration are going to come from those points of intersection, which we're going to find those on our calculator. Ooh, you know what? This one, I think, actually wants another region too. So this one, if we look at our graph, this one comes up like this, and this one kind of connects there, and there's this other region right here as well. So we actually want more than just what I was talking about before. Right, we actually want this other area here in the middle as well. So here, let me grab the thing from the calculator and show you what area we're trying to find. Okay, so we're trying to find this area and this area together, and they actually switch which function's on top and which one's on bottom. So we need to actually set up two integrals for this one. All right, so I'm going to go ahead and delete this and just clear up some of this nastiness. Let me pause the video while I clean up some of this. Okay, so what this means is this integral that I have written so far is only taking care of that left piece there, right? It's only going to take care of that left piece right here. And so I need to write another integral that's going to take care of this green piece here, right? So this is taking care of that blue piece. The integral that takes care of the other piece is going to be, I can write another integral. It's going to be the opposite direction, right? So the x squared over 2 is going to come first, and then we're going to subtract the x cubed over 2 minus 3x next. And the reason that is because the parabola is on top here in that area, or in that region for that piece. So now we need to know the limits of integration, which is going to be finding points of intersection. To do this, we're going to go to our calculator. We're going to press second, trace, we're going to go down to intersect. Okay, and we're trying to find this left point of intersection over here. It's going to ask me first curve, which just means I want to be on the cubic function. Press enter. It's going to ask second curve. Just make sure it jumps down to the parabola. Don't press like up. If you press up, it's going to go back up to the other function. If we're on the parabola, we just press enter. And it's going to say guess. Here we want to get close to that point of intersection and press enter. Looks like they intersect at -2. Again, we're using x coordinates because we're going towards the x-axis. We're going to do. We know they also intersect at 0. We can see that they intersect at 0, and then this one's going to start at 0, and it's going to go to that point of intersection that's up here on the right. So we're going to hit second trace, intersect. Let's go ahead and go closer to that point of intersection. I'm going to go all the way over here. Enter. That was the first curve. The second curve is the parabola. We're going to guess. We're going to go over here kind of close and press enter. And the other point of intersection is at 3, right? So we're going to go ahead and integrate these. Both of them, we can do them at the same time. We're going to say math 9. We're going to enter this first integral exactly how it's written here on the paper. Uh-oh. Sorry, I got to pause again. I don't know what my calculator's doing. Okay, so it's helpful to remember that I wrote this under y1 and this one under y2. So here's just y1 minus y2, and here's going to be y2 minus y1. Right? It helps me from having to save to write all that mess in there. So I'm doing math trace y1 minus math trace y2, and then dx. We're going to add math 9, another integral from 0 to 3 of alpha trace. I was saying math before. y2 minus alpha trace y1 there with respect to x, and we integrate this, and it's going to give us 10.5416. Repeating. Let's make sure we got the right answer. 10.542. Yes, we did. And again, it's important that you actually set up these integrals, right? I don't just want this answer. I want to see these integrals on there as well. Okay, last one is going towards the y-axis, right? Notice how here we have a function on the right, and here we have a function on the left, right? We can't do up to down because not one of them is not always on top. We're interested in that little region there that's shaded for us, including this. It's hard to draw just that. So when it's like this is the one where we do right minus left, and everything is in terms of y, right? Everything must be written in terms of y coordinates. So we can see here the green is on the right, so the area is going to be the integral of the green function, which is 2y squared minus 12y plus 19. And we're going to subtract the function that's on the left, which is negative y minus 4. It's very important that you put these parentheses, otherwise you won't have the correct answer. We're going to put a dy there because we're integrating with respect to y, and we need to know our limits of integration. It's nice that here they give us those. It's going to be 2 and 3. Now they might not always give these to you, so it's important to know that we need to use the y coordinates, right? So imagine this case, except the lines cross like this. We would use the points of intersection, but we'd be using the y coordinate of the point of intersection, right? We would not be using the x coordinate. We'd be putting the y coordinates up here. Okay, so this is the first part, right? And now we need to use our calculator to actually calculate it. Again, I'm going to put my two functions here, and then I will use them once they're here to integrate, just because it makes it a lot easier for me to not worry about making a mistake there. And notice I am putting in x's. There's no way to not do this, there's no way to put in y's for the calculator. Let's just graph it real quick so you can see what it looks like. We're graphing the x direction. Basically, we're going to find this area here underneath this curve, which is going to be equal to that area going that direction, right? So here we go again, math 9. We're going from 2 to 3 of 2, no, what am I doing? Alpha trace y1 minus alpha trace y2 dx, and we're getting 8.1, 8.166, so on. And let's make sure that's correct as well. Yeah, 8.1 is good. So that's that. All right, so good luck on this one. Hopefully this will be an easy one for us all to pass.